a possibility that we will have a wrong number, or it is a chance that their error can be occurred in other forms as well. So in this case, in this example, that is error in a function, we will discuss this concept. For example, let's say there is a single variable function y equal to f of x, which means the function y y variable depends on x through the function f. So the point is, what happen if instead of, for example, I want to find the value of this function at x equal to 4. So you all know what I have to do. I just need to replace this function by a value of 4. So I will get certain answer. So I said that the value of the function at x equal to 4 is f of 4. That's correct answer. That is true value. That's the exact value. But let's say I know the function, that is this function, but instead of evaluating at x equal to 4, due to certain reason, I made some error in the calculation. Let's say I replace x equal to 4 by x equal to 4.001, which is quite clear that this is not the exact reading. In fact, it is the approximate reading, because 4.001 can be written as 4 plus 0.00001. So I can say this is the exact reading plus this is the approximate reading. So this is the approximate reading. So this is the error representation of the function. So this contains error. So what will happen, just think about it. If I replace this quantity instead of 4, so one can clearly understand that you will get certain answer if the function is defined. Yes, I will get the certain answer, but this increment or this error amount in this value does not reflect the exact answer at x equal to 4. This means that in case of function, if I, or any other reason, based on any other reason, because this is just a simple example that instead of 4 I am using 4.00001, but there must be some calculation that you are performing which are dependent on each other. So you calculated certain value which is not exact, and you have to use that value in other calculation in the form of function. Then when you use it, you will propagate the error as well. So for example, in this case 4.0001 is a function, and if I replace it here, so I will not get the exact answer. Exact answer is exact 4. So this means a function, a value that has an error inside, in case of function, also develop or transfer the error to the dependent variable as well. Let me recall again for you. This variable is usually called independent to main value, and this value y is called dependent. So this means that if I made error in this function, this value that is independent variable, I will brought a similar effect or an error in a y as well. Sometimes or sometimes not. It depends on the function as well. But yes, definitely it will has some impact on y. It is not necessary the impact in dependent variable has the same magnitude as the independent variable, but it will have some impact on it. So this is the concept of the function. That what does mean? Means that if I have any function of a single variable, if I made mistake in this function, I have a simpler impact on the y as well. So what does this mean? For example, we know a very famous function called Ohm's law, which says voltage, that is V, is equal to current I times the resistance R. So this is the function. Let's say resistance is constant, so I can say V is a function of I, where R is constant, that is not changing. So I can say that this. So what happened if, let's say, during the calculation or experimental setup, by mistake instead of using correct current, my instrument gave me some reading that does not correspond to the exact value. For example, just our example. So let's say the correct reading is 1 ampere, but by mistake, due to the reason, although my intention was to note the correct current, but the instrument has an error and instrument gave me the wrong reading. Instead of, it gives me something like, let's say 0.99 something 9. So if I, instead of using 1 ampere, if I use this quantity in this formula, I will get definitely certain voltage for a given resistance. I will get certain voltage, but that voltage does not reflect the correct voltage to represent the correct situation, because I was anticipating something 1 ampere. But I said, okay, the instrument is giving 0.9 and is close to 1. Let's use 0.99. So, but keep in mind that because the function depends on the variable, so this will brought forward the error into the other quantity as well. So what we have to do in this topic, that is error in a function, we have to figure out a way to quantify the amount of error that will propagate in the function. And it is very simple concept. You have used it up to certain extent somewhere in application of derivatives. But let's recall it again, how we do that. So I hope you understand the background of this topic, in which we are just trying to formulate the error function background. Move ahead. Error in a function. Error in function. So error in a function is the correct word. Okay. So how do we quantify that error? Okay, we have a concept. If there is a function y equal to f of x, if we made some mistake in x, it will brought forth the error in a y. So what, how we quantify based on x? So let's move ahead. For example, it's not an example like from the application point of view. It is just an idea. Let's consider there is a function y equal to f of x. So if I try to compute the change in y, so to compute change in y with respect to x, that's true as well, because if I use wrong reading in x, so I will not get the exact answer of y. This means I have changed y. I have changed it little bit. So what we do, we have a very simple concept. Idea is quite simple. So idea is, if you have a y value and you put f value but with error, there is some error that I made. Instead, this could be this sign could be positive or negative. It depends on this value. It's not necessary we always add up error. We can subtract error. It's algebraic quantity. But just to represent, we are saying there is an approximate value. Sorry, this is the approximate value, and I add error in it. This will become the exact reading. So in this case, this is equal to y quantity. But if I use because this quantity is equal to exact value, approximate plus error equal to exact reading. So in this case, this quantity should be y. But we don't know what amount the error we have. So we can say, in this case, we can say whenever we replace f by x dash, that is approximate value, we will brought certain amount of error in y. Because if you recall the last example, when I said you have to take a reading from the ammeter of the current, so you just need to have a reading 0.999. You don't know that whether it's correct or wrong. So that is, for us, is x dash. In fact, it has to be a 1 ampere, but you use 0.999. So this is your x dash, and when you plug your x dash in a formula, you will get certain error in the y as well. So y is the exact reading, and you will get some error. So what we have to do here, we have to quantify this epsilon. That is how much error we have when we do this thing. So for that we have to come back to this topic, and we call it compute change in y with respect to x. If I have to ask this question to compute change in y with respect to x, so for that you all remember you just need to take the derivative of y function with respect to x, in other words f dash. So what is change in x? So let me highlight these two are just extra point, that if you know the approximate and you know the error, you will get the exact reading. But if you don't know the error part, you just have a reading which contains certain error, and if you use in a function, you will definitely get certain amount of error in a y as well. We have to quantify this quantity. So idea is uh, based on the derivative. So what you have to do, you have to find dy over dx, which is basically is nothing, is d over dx of f of x, which is nothing, which could be written as f dash of x. So when you so keep in mind that this f x dash is different thing. If you remember the first lecture, x dash means approximate value. Here it is f dash of x, which means that this is the derivative of the function f with respect to the x. So they are two different quantities, so do not mix them. So what I can say, dy over dx equal to f dash of x in this case. But let's focus here. What does these two quantities reflect? If you recall from the primarily calculus class, this is basically represent the change in y dy, and this represents the change in x. And in calculus sense or derivative sense, you may recall a word called rise over run, height over length. So these are basically the similar thing. This represents change in y dy, a small change, divided by dx, the small change occurred in x. So what I can do, I can represent them in the form of error as well. Because if you look here, this change, it's a very small change, error quantity. So this change occurred in y, in x quantity. So this means this change will bring any change into the y as well. So what I can say, I can clearly conclude that this dy is a change in y due to the change in x. So what is the change in x? We have epsilon x. So what I can do, I can write down a similar expression by making the following conclusion. The epsilon y, that is the error in the dependent variable, this is this quantity in our case, is equal to, now student, I'm connecting this equation with this equation, these two are equal. So what I can say, this part is epsilon y and this part is epsilon x. So this will become epsilon x f dash of x. I hope you understand the point. So this is basically our equation to compute the change in any function. If you recall a concept called total derivative, this is similar to that function as well. So what we have now, we have a very simple idea. In case of a function y equal to f of x, if I made any mistake in x, the corresponding change in a y is calculated by this equation. Let's call it 1, maybe somewhere you can refer during the question. So what does this mean? This means epsilon y equal to epsilon x times this function. So if I want to compute the change in y, that what amount of error it will bring into the quantity is basically equal to epsilon x, that is a change in x, whatever be the error you have incurred, multiply by the change in the derivative of this function. This is a very simple equation. However, this equation, so before to say that word, let's me write down. So what I can say, change in y is equal to, so keep in mind y means any dependent variable. It could be a voltage, it could be a resistance, it could be anything which is depending on the other value. Change in y equal to change in x, that is independent variable, multiply by derivative of y with respect to x, that is an independent variable. If you compute these two quantities, you will get the change. Now once you have this change, you can add in an exact value to know the what change exactly happened into the value. But this is the formula. There are two possibilities. A change could be positive or a change could be negative, because depends on the slope. If this quantity is even positive, just because this could be positive, negative as well. But even if this is positive, then this change could be positive and negative as well. So it depends on the function. So this change could be positive or negative. So if you brought this quantity here, so you will get either quantity which is greater than y or less than y, which means that depending on x, you will bring a different type of error which may increase the value with the exact value or decrease the value as compared to the exact value. This is very simple idea. It's not something difficult concept, but this is how we connect the story that okay, we have a function and let's say we made some mistake which we know how much amount we have mistake, so what amount of error it will brought into our calculation. So we have to use the simple formula, this change in this. I hope you understand the concept behind it. So this is the error quantity. Now student, this is the error which is related to the function, and we know that this amount represents only error. So if this amount represents only error, then we can represent that error in the form of absolute error, a relative error, or a percentage error if you want. So this gives you just the magnitude of the error based on this mistake. But you can reflect it in the form of present error or percentage error, any other error. How you do that? It is just an extra part, but let me show you. For example,